Let's prove the second part of Schur's lemma. This time there are two irreps, unitary actually, in general on different spaces, V and W. And then there's a linear map from one space to the other space, A here. And this linear map again commutes with these representations in this sense here. We can either first apply one of the representations and then map from V to W, or first map from V to W and then apply the representation on W, and we end up in the same place. So if we have that, then well, either this A is 0, that's the trivial way in which we can always satisfy this equation, or the interesting case, if this A is not 0, then the two irreps are unitarily equivalent. Okay, let's show this. First copy this condition here. A times gamma of G is gamma tilde of G times A for all group elements. Let's take the Hermitian conjugate of this. And we have that, Hermitian conjugation turns the order around. So we have gamma of G dagger times A dagger is the same as A dagger times gamma tilde of G dagger. Okay, and this is true for all G. So let's say we do this for one, we write down the first equation for one G, and then we write down the second equation for the inverse of the original G. Holds for all G, so we can write the G inverse here. Now the G inverse and the dagger, since it's a unitary representations, just cancel, and we really have that gamma of G, A dagger, is the same as A dagger gamma tilde of G. Now we're ready to play. Now we look at, let's say this here, A dagger A times gamma of G. What's that? So A gamma, that's what we have up here. So we can replace this, copy the A dagger, we can replace this with the gamma tilde of G times A. And now we have A dagger gamma tilde, see this from here, so we can replace that by a gamma of G A dagger, and the A which we already had. And what happened? We just took the A dagger A and commuted with the gamma of G. So according to Schur 1, A dagger A is a multiple of the identity. If this constant C here is 0, then we are in this case, and the interesting case is non-zero C. Oh, and by the way, this C here is a real number, since this is Hermitian, A dagger A. So it's a real C. Now the interesting case, as I just said, is non-zero C. So for C non-zero, 1 over square root of C times A is unitary. Yeah, why is that? Just divide this equation here by C, put each of square root of C to each of the factors here, and then we see that U dagger U is the identity. So this is unitary, and now we go back up here and divide this equation by 1 over square root by square root of C. So then we have that the A's become U's. So then it follows that, let's say, multiply this equation with u dagger from the right. Then we have u gamma of g, u dagger is equal to gamma tilde of g. So they are unitarily equivalent.